Okay, so we've seen that if x is the position in world frame, then you could write this. This is just a recap of what we wrote down earlier. So x position in world and body frame respectively. Okay, where x, you can write it as, it has a constant of, it says 0 for the constant part and a vector for the non-constant part, and x bar would be 0 x bar. Okay, so there is a derivation which basically, in order to do that, what you need to do is you need to take x and x prime, take its derivative, and then once you take the derivative, there is a steps to show that using v expression similar to v equals omega cross r, that omega is related to the quaternion. So that expression, which I will write down, which will save us some time because I don't want to derive it. So it can be shown that q dot equals half omega q. And then q dot equals half q dot the big omega, where omega is angular velocity in world frame. Velocity in body frame. Okay, so when you take that product, there's a way in which you can do multiplication between two quaternions. So omega has to be treated as a quaternion. In fact, what you'll do is you'll write omega as 0 omega, and then this big omega will be 0. Right? So the 0 means the constant part is 0. And then the non-constant part is basically omega x, omega y, omega z, and then same for the body frame omega. Okay, so you'll take omega as a quaternion, you'll take q as a quaternion, you'll take the product. There's a specific way you take this product for a quaternion, which we did some time back, and then you can get q dot. But once you have q dot, that is your quaternion rate. This is similar to your Euler rate, right? Euler rate is basically, then once you get the Euler rate, you can then find the Euler angles by take the integration of the Euler rate. So that's what you'll do here too. Once you have q dot, you can integrate that, which is something which we'll do later on, to get q. Okay, so with this, that's basically is everything we need to know about a body which is rotating in the world frame. We have, remember, if we had to compute its position as a linear velocity, which is x dot, y dot, z dot, and we were also interested in computing its angular velocity. So there are multiple ways of doing that. One way is using r dot, but r dot is related to omega, small omega, and big omega. It's also related to Euler rate, phi dot, theta dot, psi dot, which I wrote down, but there's a singularity. And then the last way to do it is through quaternion. So we've seen the spectrum of ways in which we can relate the angular velocity of a freely floating body.